Welcome back, future medicos. Today, Mr. Karthikeyan will be covering the topic adrenal gland from class 11 biology chapter 22. But before handing it over to Mr. Karthikeyan, I will talk about a test series that is going on that might be useful for your exam preparation. So if you look at this is conducted by Unacademy and it is called Unacademy Champions League or UCL. So this is a completely free test series and it happens every Sunday. So last Sunday there was a test on physics and tomorrow, that is November 8th, there is going to be a test on chemistry. Some of you have registered last week, you have posted some comments, and in case if you have not registered yet, I request you to go ahead and sign up for this particular test. And this test will be happening tomorrow, that is at November 8th between 1 p.m. to 2 p.m. So every week there will be a test. Every Sunday there will be a test on physics, chemistry, and biology. So if you are taking for NEET exam, it will be physics, chemistry, and biology. If you are focusing on IIT, JEE also, then it will be maths, physics, and chemistry. So accordingly, you can sign up and take the tests. Now these are foundation level questions. There will be about 25 questions in the test, and each question will carry 4 marks. And if you answer it incorrectly, there will be a negative 1 mark. So that's exactly the same pattern followed in NEET exam. So go ahead and give it a try. Now I will hand it over to Karthikeyan to start today's lesson.
So hello everyone. In this video we are going to talk about adrenal gland, which is very important gland in our body and also very important for your exam. So one ideal topic that we all must be thorough with. Now the question is, what is this term adrenal trying to convey? See, in Greek, okay, any term that is having a prefix ad, it refers to above. In anatomy of flowering plants, if you guys remember, we have got something called adaxial, abaxial. We try to compare it with the monocot and the dicot leaf regarding the number of stomata that is present. So ad means above. So in this adrenal, which means above renal, this gland is located above the kidney. So where it is located, it is on the anterior side, which means it is on the front aspect of your kidney. So above the kidney on the anterior aspect is the location of adrenal gland. So if you look at the structure of adrenal gland, we have got two parts. One is called as the cortex, the outer zone called as your cortex, and inner zone called as medulla. So adrenal gland is divided into two, outer cortex and then inner medulla. So the layers of these adrenal cortex and the hormones that are concerned with that is an important one for you. So if you take cortex, we have got three zones. So this cortex in turn, it has been divided into three subdivisions or three zones. The first zone is called as zona glomerulosa. Zona glomerulosa. The middle layer is called as zona fasciculata. The middle layer is called as zona fasciculata. And the inner layer is called as zona reticularis. So the outer layer, I'll just write it as OL, ML, and so this is OL, that is the outer layer, ML is the middle layer, and IL is your inner layer. So three layers, yes. So I usually ask my students to remember with an acronym GFR. So you all know what is GFR, right? You all are well versed in excretion, glomerular filtration rate. So similarly, I've got something here called GFR, glomerulosa fasciculata reticularis. So from the outer aspect to the inner aspect. So with respect to zona glomerulosa, we have got an important group of hormones called as mineralocorticoids that are concerned with this layer. So the layer of zona glomerulosa of the adrenal cortex, it secretes a group of hormones called mineralocorticoids. So what is the most important mineralocorticoids? It's your aldosterone. So again, in regulation of excretion, we will be studying. It's an important question. So the main mineralocorticoid is your aldosterone. Next, zona fasciculata is the middle layer. It is concerned with secretion of a group of hormones called as glucocorticoids. So the main important glucocorticoid is your cortisol. It has got a very important clinical implication. I'll tell you in short. Next one is your zona reticularis, that is concerned with secretion of some amount of sex hormones. Now in the next video, we'll be talking about gonadal hormones, wherein again we'll be talking about the same set of hormones. The thing that you must understand here is, say suppose in my blood there are 10 units of estrogen. It's an hypothetical situation. Say suppose there are 10 units of androgens in my blood. Not all 10 units are going to come from my testes, right? So say suppose out of 10 units, there will be 7 units that is synthesized by the testes and remaining 3 units will be from my zona reticularis. So we have two important regions or the places where the sex hormones are being synthesized. So one is the gonads, another one is going to be the adrenal cortex, that too especially in the layer of zona reticularis. Now talking about important aspects of these, first one on aldosterone. Now, aldosterone is a mineralocorticoid, so it is concerned with some mineral ions. So, main important thing that you must know is it is concerned with sodium reabsorption. So, this aldosterone is going to increase sodium reabsorption from the renal tubules. Sodium reabsorption from renal tubules. So if there is excess of aldosterone, then it is going to lead on to what is called as hypernatremia. So what is this terminology trying to convey? Hyper, right? More, excess. When I say natri, it refers to sodium levels. Okay. So emia. So in my further lectures, I'll keep repeating this. See, if there is any terminology ending with EMIA, which means it is referring to plasma. Okay, before we have seen few terms like hyperglycemia and then hypercalcemia, hypocalcemia, all that, right? So everything ended with EMIA. So when there is a suffix ending with EMIA, then it means that I am referring to plasma. If it is ending with URIA, which means it is going to depict that particular constituent in the urine. So if I say, for example, glycosuria, which means glucose in the urine, proteinuria, protein in the urine, proteinemia, protein in the plasma. So if I add a prefix like hyper or hypo, it is going to say that there is an increase or a decrease. Okay, so hypernatremia. So hyper means more, natri means referring to sodium, EMIA means plasma. So that's increased sodium levels in the plasma. So when there is excess of aldosterone, it leads to increased sodium levels in my blood. Now, next one is zona fasciculata. So main hormone that it is going to secrete is glucocorticoids, especially we are talking about cortisol. Now it's a NEET 2020 question also. There was a question on cortisol. Now, what are the things that you must know about cortisol is its function. See, it's a stress hormone. So whenever we are in some stress condition, this cortisol is going to bring back to normal state. So whenever you are in stress, so there is going to be extreme fatigue. So you do not have proper amounts of energy. So there should be energy levels to be replenished. So what is going to happen here is there is going to be hyperglycemic state being accomplished. Okay. Now, if you remember my glucose homeostasis video, there we saw glucagon is an hyperglycemic hormone that is going to increase the blood glucose level by stimulating two processes. If you remember, one is gluconeogenesis, another one is your glycogenolysis, breakdown of glycogen, breakdown of glucose. But here if you take cortisol, it acts in different way, that it can stimulate hyperglycemic condition only by stimulating gluconeogenesis. It has no role to play with glycogenolysis. Please take this point. Even though we say hyperglycemic state, I do not want you guys to get confused, but make it very clear. It is not concerned with glycogenolysis, but it is predominantly concerned with glycogenesis. It might confuse you. See, when I say hyperglycemic, almost okay, majority of its action is going to be hyperglycemic. Only one exception is it is not going to take over glycogenolysis. It is in turn it is going to stimulate glycogenesis. So how I can interpret this contradictory statement is, so during stressful condition, listen carefully, cortisol is being released. This cortisol by means of gluconeogenesis, and along with that it is also going to inhibit cellular uptake of proteins. This was the question. Which of the following statements is not true with respect to cortisol was the question. Okay. Inhibit cellular uptake and protein metabolism. And it has one more important clinical aspect, that is it has got an anti-inflammatory role. Okay. So now what I want you guys to understand here is, when I say hyperglycemic state, it is mainly going to be accomplished by means of gluconeogenesis and also by inhibiting the cellular uptake and protein metabolism and all that. So once the sufficient amount of glucose is reached, so say suppose I need to replenish the glucose level by 50 units. Again, just an example. Say there are about 75 cortisol I have now. 75 units of cortisol is with me, but I need only 50 units of glucose to be replenished back to attain this hyperglycemic state, which means remaining 25 units are extra for me. Assuming that 1 unit of glucose is going to increase the glucose unit by 1 level. Are you able to understand? I'll repeat the statement again. Cortisol is going to bring about an hyperglycemic state. So here I have 75 units of cortisol and I need to replenish my blood glucose level just by 50 units. Assuming that 1 unit of cortisol is needed to replenish 1 unit of glucose, so 50 units of cortisol is required for replenishing this 50 units of glucose. Because 50 units of cortisol is required for replenishing 50 units of glucose. So remaining I have got 25 units, which means there is going to be excess of cortisol. So there is going to be excess of glucose present. So that excess 25 units of glucose that is going to be synthesized by this extra 25 units is going to take this pathway of getting converted to glycogen. So once sufficient amounts of glucose levels are obtained in the blood and still there is excess of glucose present, this cortisol is going to take all that glucose, get to the liver and get converted to glycogen. So cortisol is also going to favor glycogenesis. Okay, so this point is not important for your NEET exam, but this point is important. It is not going to stimulate glycogenolysis. So it is going to stimulate gluconeogenesis, inhibit cellular uptake and protein metabolism. All these I can say. But please do not utter a word on glycogenolysis. Now, anti-inflammatory role, and it is going to alter the immune response. Again, a very important function. In clinicals, whenever we have got some infections, we try to give cortisol injection. So we have got some preparations like hydrocortisone, prednisolone, all these are lots of drugs in this group of glucocorticoids. So all these drugs we actually give when there is severe infection, so that the inflammation of level is going to be decreased. So this is again for your clinical purpose, not important. Just know it has got an anti-inflammatory role. These are some points with respect to glucose. I mean the adrenal cortical hormones. Now let us talk about adrenal medullary hormones. So we have just spoke about aldosterone. We have spoke about cortisol, and about sex hormones we'll be dealing with the gonadal hormones. Okay. Now With respect to adrenal medulla, we have got two important hormones. So here I have mentioned a picture with two F words. One is fight, another one is flight. So all these are some emergency situations, right? If somebody is not trying to attack us, they try to snatch our chains, we try to defend. So again, it's a fight situation. Or you see a dog affected with rabies, so which will try its level best to attack us. So it will start chasing us, we try to escape, we try to flight. During such emergency situations like fight, flight, or fear, we all would have experienced this dreadful situation, right? Especially during our results. If our chemistry teacher or physics teacher comes with our answer sheets evaluated, during our PTM, everywhere at any point of time, we are going to have a checkpoint with this fear or by this fear, I can say. So during all these emergency situations, there is going to be a particular hormone that is going to be released that is going to combat this stress. What is that hormone? It is adrenal medullary hormones, and chemically we call them as catecholamines. So because it is an amino acid derivative, directly an amino acid derivative, I call them as catecholamines. So we have got two catecholamines. So we have got two adrenal medullary hormones. One is your adrenaline, or referred to as epinephrine. Another one is your noradrenaline or norepinephrine. I guess you would have heard these terms already. If you remember your neural control and coordination chapter, there somebody would have mentioned about the neurotransmitters. Even if you do not know, take this point. These adrenaline and noradrenaline, they are the neurotransmitters of sympathetic system, of sympathetic nervous system. So we have got two types of nervous system, sympathetic and parasympathetic. Neurotransmitters for sympathetic nervous system, sorry, we have got adrenaline and the noradrenaline. So for parasympathetic, we have got, I'll just write it as PARASMP. Parasympathetic, we have got acetylcholine. Again, an important NEET question. Acetylcholine. So what is the neurotransmitter for parasympathetic nervous system? Which of the following is the neurotransmitter for sympathetic nervous system? Or sometimes question can go like, which of the following are true with respect to parasympathetic and sympathetic? That we'll discuss in detail in neural control and coordination. So with respect to this, you just have to know the nature of neurotransmitter. So adrenaline, noradrenaline for sympathetic and acetylcholine for parasympathetic. So these are some emergency hormones that is going to be stimulated. So just imagine during fear or during fight or flight, what are the things that you need? Now, when you are in a flight mode, meaning you are being chased by a dog, so you keep running continuously till it stops barking. So till all the time, you need continuous oxygen supply, continuous heart rate, and all that. See, just understand, since I said these are concerned with your sympathetic pathway, just know, take this point alone. It is going to cause dilatation of the pupils and increase in cardiovascular. Okay, thing is, it is stimulatory in all your systems except GIT. So except your digestion and absorption, sympathetic nervous system is going to stimulate, increase every parameter. Like if I say cardiovascular, it's going to increase the heart rate, it is going to increase the BP, it is going to increase the pulse rate and hence the cardiac output. Dilatation of the pupils. So almost it is concerned with stimulatory action. So it is stimulatory in all the systems except gastrointestinal. So you can just remember something like S for S. Sympathetic is stimulate. Right? So these are the things that you must know with respect to adrenal medulla. So most important question that they ask you is the stimulus. So 3 F's: fight, flight, fear. What is the net result? it is going to have a stimulatory action. It is going to increase dilatation of the pupil. It is going to increase the heart rate, BP, cardiac output. It is going to cause piloerection, that is goosebump moment, all that. Okay, these are some net result of stimulation of your adrenal medulla. Disorders, yes, sometimes it has been asked in your NEET exams. You just have to know what is the name of the disorder. If there is an hypoadrenalism, what is the name of the disorder due to hyperadrenalism? Due to hypoadrenalism and then hyperadrenalism. So the disorder due to hypoadrenalism we refer to as Addison's disease. We refer to as Addison's disease. Not so important. Yes, can be a question, but hyperadrenalism is going to cause a syndrome called as Cushing's syndrome. So hyperadrenalism leads to Cushing's syndrome. Hypoadrenalism leads to Addison's disease. So some symptoms, because if I if I leave it here, it will be incomplete. So Addison's disease, if you take, there is going to be decrease in BMR, then decrease in BP. Just whatever we learnt now, it is going to increase, right? So there's going to be ulta here. There is going to be dehydration taking place. So these are some symptoms of Addison's disease. Similarly, if we talk about Cushing's syndrome, I can say there is going to be edema. Already seen in thyroid, what is edema, right? Accumulation of fluid in the interstitial spaces. So because of that, there can be puffiness of the face, swelling all over the body and all that. Then there can be hyperglycemia, because we saw it has got an hyperglycemic effect. There can be hyperglycemia, and then there can be increased protein catabolism, etc. So these are some symptoms with respect to hyperadrenalism. So with respect to adrenal, you just have to know what is the stimulus for adrenal medulla, what are the 3 layers of adrenal cortex, and what are the hormones, and please know the functions of aldosterone. And then the statements with respect to cortisol, especially, it is not going to favor glycogenolysis, only gluconeogenesis. So these are some points. This was NEET 2020 question. We'll meet in the next video. Until then, thank you. Bye bye.